Welcome to watch this presentation about the BAL's capabilities for cloud resource consolidation. So what to consolidate? Basically, if we manage to find any way to effectively consolidate the cloud infrastructure resource usage, it will reduce the costs. Primitives that cost in the cloud. Pricing calculator that's available in the Windows Azure pages is basically vendor agnostic. All the major public cloud providers are quite equal in the price. Primitives that cost in the cloud are standby costs. Storage, that's $7 per gigabyte per month. That's what occurs regardless of what you do in the cloud. If you have maintained storage, that's how much it's supposed to be paid for locally redundant storage. That's the storage, by the way, which is 3 times redundant over the same data center. Then the action costs that occur when something is done in the cloud are as following in a primitive level. Storage transactions, which equal to $1 per 100,000 transactions. Outbound network is $12 per gigabyte, and computing, it's depending on what size of instance or resource is used, it's from 2 cents to 1.8 US dollars per hour, and then it goes upwards if licensing or bigger instance combinations are getting used. The costs are bound by realities. Storage is maintained, it's online, it's scalable, and it has capacity. Network is also maintained in a capacity wise, it has the available bandwidth. Computing, it's basically active virtualized hardware. It flavors in memory an amount of cores, and on some special occasions there could be graphic cards within or custom providers, something that's really, it's something concrete that's been reserved to be used, so that's why it costs. If you compare, or if one compares existing resources that are on premises at the office or at home, it feels expensive. Basically, computing hours, for instance, are quite expensive. However, if you include maintenance troubles and costs, available scalable bandwidth, and all the other factors in, it's not that expensive. It's always there, functional, and it scales. So let's use some numbers to get a picture. What can I get for 100 US dollars? I can get 1.5 terabytes of storage for 1 month. Of course, with the same cost I can have more for a longer period of time, but I'll use the month as an example. I can get 1 billion storage transactions. It's quite a bit. It's a lot, and often that's not the component that's causing the costs. But storage transactions do cost because the activity and the resources in the storage require resources in the data center. For $100 you also can get 833 gigabytes of network outbound storage, not storage, capacity, bandwidth. And that's also not that much compared to any high enough bandwidth landline that you can have in the office or at home, but that's also a bandwidth that's available close to the very scalable storage. So it has some certain functionality that beats the local on-premises networks, and it scales. Then what you get on the area of computing is 55 to 5,000 hours of computing. That means 2.3 days to a bit more than a half a year of computing. And that's now the question. What is the computing? It will be the target of this consolidation because it's the most expensive component and it has more fluctuation and room to consolidate. So what is computing? Computing is a computer or virtual machine that is powered up and running. The cost is to pay for the capacity that is available. Then the logical question would be, what if I don't actively compute anything? Why do I pay for that? Online services is computing. Servers serving web pages, database servers responding to queries. Well, what about the time when they are idle? Well, cost to pay comes from available reserved capacity, so that your servers are responding to your average user load when you know that it's occurring. Basically, it means that these average loads are estimated, and in a modern way, reactive or even proactive autoscaling can occur when the estimated user load start to come up. But there is always something running that you have to pay for to be prepared for the scaling. Same thing also for on-premises. So how much computing is then needed? Well, cheapest, the smallest instance is $50 a month. That's the lowest price range that I entered in the range. It has 768 megabytes of RAM, and it shares the CPU core. So that's not much for anything real-time responsiveness for a web server, for instance. It does run a web server, but it has its limits when more users jump in. However, it still has quite a bit of CPU cycles during the month, much more than average Office server uses for its tasks combined for that same month. So what if computing could be counted as CPU cycles? Let's remind ourselves a bit on the ball model. The ball is pure distributed model. It's distributed to security groups. Platform or instance or installation level owns no data. It's only providing the core infrastructure service that can enable the group level processing and interaction. Each group owns the information within itself. This also holds true for the account. And processing is ran within the group's context. So basically the group will own and guard for whatever is processed in its context. It means that it can also be measured with all the things that go in and out, and the CPU processing when it's acting on the group. So the core only provides infrastructure such as network and storage that's required. So let's see some numbers with the ball unified processing with real website group. I'll introduce the scenario. It's a company website. It's a full demo site, but with proper kind of content to demonstrate. It has 30 content pages. It's now in the numbers scenario 300 edits combined per month to maintain them. That's about 10 edits per page. It also is estimated to have 1,500 visitors a month, which means it's 50 a day kind of rate. Each land to homepage and click 8 to 9 articles. So then to the numbers. Simulation load scenario I'm showing in the graph and going through what's on the graph. I ran the load test content beforehand. It's a website with the 30 articles. On the midnight, around these hours, I ran 1,000 requests plus the 1,000 visitors scenario with page loads and few article clicks. It resulted something like 1 gigabyte of outbound traffic from the site. Then in the CPU cycle, there's a spike when I ran the patch of the operations on, well, the remote browser. it used the group's resources to calculate the usage reports, just implemented, so it's now coming currently from the group. Then from the 9 to 10, 300 edits of articles, and from 10 to 11 again visitor simulation for 500 times. So basically I'm running this scenario within few hours and just show the resource load during those hours. It's monitored request by request basis, so it doesn't matter if the requests are a span throughout the month or occurring within few hours. The same time, from the Azure portal, we can see network bandwidth on the midnight is been peaking at almost 400 megabytes, and the CPU cycles for the web roles is somewhere spiking at 7%. We got a higher level of the numbers. I go back to the scenario. There are two bars here. The lower ones are the real-time CPU time, thread time counted. However, the higher ones I got in a way that I counted milliseconds through when the request comes in the begin request, and when it ends. The time between that, regardless of how much the CPU was idle, is now counted as that okay, the system possibly was more or less busy during that time. So we are very conservative and cautious for not overstating anything. Basically the machine was able to pull off and handle full request during that time. So that's our baseline marker. That's when I claim the used milliseconds is coming from. So the comparison numbers then in this example, I have the monthly summary here. Pricing instance sizes are compared with the small instance and extra small instance. We run the ball right now on the extra small instance without any issues. The equal numbers are network outbound gigabytes, which is close to the 1.7 gigabytes. Network pricing is counted in as before mentioned 12 cents per gigabyte, so it's 0.2 bucks. Computing hours in the ball effectively are 1.7. Traditional single small instance would be 750 because it's all the time running. Traditional redundant single instance, small but double instance would be 1500 computing hours. So computing hours price is in the ball, because it's kind of calculating only the used cycles for this group, is 14 cents, whereas it's $60 and $120 respectively on the other traditional, where you pay for the reserved capacity. Cost comparisons are interesting in a way that the ball is 0.28% of the cost of the most expensive redundant comparison on the small instance. It means that the relative cost saving for this size of website scenario would be 99.72%. Now I'm shortcutting storage in this picture completely, because right now we first implemented the monitoring for varying costs. But the storage in this group right now, it has 300 megabytes of storage in various of ways, redundant. So it doesn't change the picture that much. Extra small instance size comparison is also interesting because the ball is running right now on these without any issues. It's still beating the traditional extra small by the same kind of margins. 50 bucks is not that much, but for the ball it's 24 cents for handling this kind of capacity. Then let's jump briefly to the demo. I'll show what kind of a group I used and where the reports came from. So this is I used the Firefox Sentinel, if I recall right, the tool to simply duplicate my actions on the website. I generated 30 articles in the site and edited them with the UI 300 times on the tests. The web presence of the group is like this. Equal content, kind of when you click it loads somewhere around 8 kilobytes of article on each click. So anyway, with 1000 loads we get something like a gigabyte of traffic. Then the actual report is visible here. It's done today, so these numbers are actually for real. They are a bit different now. There are some spikes of my tests on the evening. We are around total computing seconds. It's 2 hours now for serving all the stuff. Total network outbound is 2 gigabytes. And the numbers are a bit different, but still the total price is quite a low compared to anything reserved. Okay, so I'm looking forward to put this up on all of the groups visible during the coming week, and hope you enjoyed the possibility to see what happens when the CPU cycles can be counted and paid for without the reservation for them. Thanks.